Hello friends, in this problem there are two concentric rings of radii r and 2r which are placed at the with their centers at origin. Now the two charges plus q each are fixed at the diametrically opposite points of the rings as shown. Now the smaller ring, this is the smaller ring. Now this smaller ring is first rotated by an angle of 90 degree about z axis, and then it is again rotated by 90 degree about y axis. Now we have to find the work done by electrostatic forces in each of these steps. Now in the last part of the problem, if the larger ring is rotated by 90 degree about x-axis, this larger ring is rotated by 90 degree about x-axis, we have to find the total work performed in all the three steps. So as per the initial diagram that was actually given to us in the problem, let us first draw the initial diagram that was given to us in the problem. There were two circular geometries or circular rings such that initially these charges were arranged in a same straight line. And the radius of the two rings were given to us as radius were given to us as r and 2r. So radius were given to us as r and 2r. Now further, it is given that initially the smaller ring is rotated by 90 degree about z axis. So as you can imagine, on rotating the smaller ring by an angle of 90 degree about z axis, the new configuration of the charges will appear to us like the position shown in the diagram. Now it is clear in this configuration that the potential energy of interaction between these two pair of charges as well as the first and fourth charge, it is remaining unchanged or it is remaining same. The only change that is occurring is in the potential energy of these two charges that I am highlighting, these two charges, due to the charges on the outermost rings, right? So let us only find the potential energy of this charge q. Let us first find the potential energy of this charge q. It can be written as k q by r, that is the distance between these two charges, plus the potential energy of this charge due to the second charge present at the periphery, that will be equal to k q by 3r. Same potential energy will apply for this second charge q, which is placed on the circumference or periphery of innermost ring. So we can write the total potential energies of these two charges due to outermost two charges is equal to this expression. Here I am neglecting, as I have already said earlier, here I am neglecting the total potential energy of the system, where I am neglecting the sum of potential energies of these two charges due to each other, as well as the potential energy pair formed by the two extreme charges. Similarly, the final potential energy of this charge due to the two charges present on the periphery of outermost ring can be found with the help of basic geometry. We can write the distances will be equal to r and 2r, and this distance will be equal to root 5r. So the final potential energy will be equal to kq by root 5r, that is the potential energy between these two charges. Similarly, there will be yet another pair, and this will be the third pair, and this is finally the fourth pair. So we can multiply this expression by 4. Now we know that work done in first step by electrostatic force by electrostatic force will be equal to ui minus uf, that is 8 by 3 minus 4 by root 5 times of k q square by r. Now in second step it is given that the It is the second ring is again rotated by 90 degree about y-axis. Now you can imagine that in this diagram, if the second ring is now rotated about this y-axis, let me redraw the y-axis once again. This is the y-axis. Now if we are rotating the second ring about y-axis, there will be effectively no change in the distance of these two charges from the two charges appearing on the peripheries of the outermost ring. So we can say that work done in second step is equal to 0. Further, the third step is indirectly just the opposite of first step. So we can say that the work done in third step will be equal to negative of the work done in first step. So net work done will be equal to net work done after all three steps will be equal to 0.